So we kind of talk about notebooks, right? Notebooks, your IDE, your portable window into Kubernetes and Kubeflow allows you to develop functions, develop pipelines. But once you kick off a pipeline or you kick off some job in your notebook, what happens, right? Where do Kubernetes and Kubeflow really live within that? And that's what we're going to hit on next. So what is Kubernetes? Kubernetes, you've maybe heard it referred to as the data center API. You've maybe heard, some DevSecOps, MLOps, whatever ops. A lot of times under the hood, they're talking about leveraging the portability and composability of something like Kubernetes. It's designed for managing containerized workloads and services. And this is a little confusing. We mean services as in a microservice. And we mean services as in it handles a lot of load balancing power for microservices. So there's something in Kubernetes called a service. And what that does is that allows you to reference that service so that if containers come and go, Kubernetes will still give you access to them. So it's really focused on simplifying a lot of the problems that you ran into traditionally running containers. It's very declarative. So you do your desired state and it's very automatable. That's the whole point. You have these controllers and operators, which we'll discuss in a little bit. And it allows you to run these distributed systems resiliently. So it's consistently watching your environment, consistently making changes, as well as confirming you have that desired state. So Kubernetes is often described as a platform in itself. So some people think, okay, this is a Kubernetes platform, but really the power of Kubernetes is to abstract your infrastructure. And a lot of teams you'll find are building their platform on top of Kubernetes. So Kubernetes can be seen as kind of this engine. It's really complex, but it's also very orchestratable. It's very portable. It's awesome. But again, due to the power and all the different pluggabilities, it can be overly complex. So teams are actually building a platform on top of it. A Kubernetes cluster it's got two planes, right? It's got the worker nodes that host your containerized applications. They host pods, which we'll talk about a little bit. And that lets you distribute stateful applications. It also has control plane node control plane that is handling the desired state. That's got your etcd, that's got managing everything and making sure things are up healthy. So why is this relevant to the Kubeflow ecosystem? Well, Kubeflow is actually running on top of Kubernetes and helping orchestrate and tell Kubernetes how to run these workloads. So Kubeflow understands how these workloads should be ran, and gives you those SDKs so you can work within your notebook and push out that desired state to inference, that desired path to production with a Kubeflow pipeline, and have that handoff between machine learning teams and then operations teams. And as well as kind of the fine tuning, the administration things such as resource management and administration of environment, gives you that desired state, gives that observability and control. So what is a container? A container, similar to a VM, right? In that there's VM, you can see as a virtualized server. Containers are virtualized processes, right? So we've actually increased the granularity that you can start to take what used to be this kind of monolithic, giant, hard to scale deployment. And we've cut it up into virtual services that can come and go. And as they come and go, we can present to them CPUs, memory, file systems, et cetera, so that you could restart a pod. It can find the appropriate volume. It can get that container what it needs. This is relevant because Kubeflow takes advantage of the container isolation. So it really helps us, as you define steps within your pipelines, it can spin up a pod or a container that's there that has all the imports that you need, get it the right amount of resources, get it that volume, run that step regardless of the underlying infrastructure, and then hand it off. So you have that reproducibility across machines and clouds, right? This is the idea of a container is there's none of this, well, it worked in my environment. Well, as long as you have that container, it should work on any environment. And with pods and Kubernetes, you can start to choose how you want to scale that. So that's why with containers, we had to have pods. So pods, really, when we talk about Kubernetes, Kubernetes is an orchestration system. So Kubernetes is not creating pods, it's telling something that it wants a pod, right, or a container. So Kubernetes actually works with what's just called a container runtime interface that works with some container engine. This is why you often hear the confusion of like a Docker container. Docker is building the containers. on behalf of Kubeflow or on Kubernetes and Kubeflow. So a pod is the smallest deployable unit that you can create and manage in Kubernetes. It can have more than one container. So in Kubeflow, we have Istio sidecars that handle mutual TLS and authentication. So that actually sits as kind of a proxy in front of your pods. You can run multiple containers as well as logging containers. There's all sorts of cool sidecar infrastructures you can do. Kubeflow components run in pods, right? So when we are creating a Jupyter notebook, it's within a pod. We are creating pipeline steps and execution, and we're serving models. We're using a pod. And since a pod is a well-defined barrier for our virtualized service, we can start to use that for desired state and say, hey, this is exactly what a pod needs, regardless of your environment, and start to really make your applications reproducible. How can Kubernetes do this? Well, Kubernetes does this with operators and controllers. So you might have, we all kind of heard of controller, and then there's control loop, which is the babysitter, right? Which is making sure things are as they are expected. A controller can be as simple as adding an annotation, right? Confirming that you have the right annotation on a pod, or confirming that this the node has the right taint. Controllers are really what powers this GitOps conversation we have, which is I have some declarative format and I want it to be adjusted in my environment. A more powerful application-specific version of that is an operator. So an operator lets you use a declarative manifest in a simplified, abstracted way to deploy an application. So you declare it with YAML, which is going to convert a kind of JSON handle all the stuff on etcd. And once it sees that desired state and applies that state, it'll continuously correct your environment. So operators are again more application specific, versus a controller is just kind of that loop and handling it. Within Kubernetes, we have a training operator. Or within Kubeflow, we have a training operator, which is a custom resource, makes it easy to run distributed or non-distributed, right? TensorFlow, PyTorch, Apache on Kubernetes. And then we have a notebook controller, which is actually taking that custom resource definition that is a notebook and making sure that it creates a pod and handles that. So sometimes a controller's job is just to handle a custom resource definition, which is a little bit in the weeds, but a custom resource definition helps us then get what we need from Kubernetes. Again, why Kubernetes is really cool, really extensible, but also can get really complex really quickly. So it's nice to have a platform that manages that for you. Here's the classic visualization of Kubernetes. Control plane on the left here for me, and then you've got your nodes. Each node can run kind of on its own for a bit. It's got this thing called a kubelet. Kubelet's reaching out to the control plane, and then Kubernetes is reaching out to your cloud provider to get what it needs. So this is definitely, if you revisit, or if you go to the kubernetes.io website, this is worth taking a look. This is a vast oversimplification, but this is Kubernetes.